Good afternoon, Bell Museum friends. The adventure continues and we have lots more Space Fest to go. Thank you once again for joining us this afternoon. I'm Amber, the Public Science Events Manager here at the Bell, and I hope that you'll check out our website to learn all about what Space Fest has to offer. We have continued talks going on this afternoon and all day tomorrow, and there's lots of activities on the website where you can share your projects with us on social media. First and foremost, we want to very much thank Ruth and John Huss, who support Minnesota's Astronomy Classroom for this programming and a variety of other astronomy programs here at the Bell Museum. So as our adventure continues this afternoon, I am happy to say that we have a special space scientist with us. We are joined right now by Dr. Paul Romani, who works with NASA's Goddard Space Flight Center. He's currently working with the Juno spacecraft magnetic field experiment that's studying Jupiter. But prior to that, he was also part of the science teams and the operations teams for the Cassini spacecraft, which explored Saturn and its moons. And today he'll be taking us on a journey to learn more about the Saturn system. So Paul, I hear you have a mission for us. Tell us more.
Okay. Hopefully I just unmuted myself and I just started sharing my screen. And I'll just start the slideshow. Okay, so unfortunately first, the lawyers got to me, so I have to do a disclaimer. I work at NASA. In fact, I'm a federal civil servant. So yes, I am your tax dollars at work. If you think, however, if you think anything I say is official NASA policy and anything, well, I also have some Nigerian bank funds that need transferring, and please get in touch with me. So what I want to talk to you about today is I'm going to let you put together and choose an astrobiological mission, should you choose to fund it. I'm going to ask you specifically, do you want to go to the moon Enceladus or to the moon Titan, and see whether you agree with which moon NASA picked, and I'm going to give you some information to help you make your decision. So for many, as Amber mentioned, for many years, I worked on the Cassini-Huygens mission to the Saturn system. And this was a joint NASA, European Space Agency, Italian Space Agency spacecraft. So this is one hint for you, make your mission international. That way you can get more money and spread out the cost. And while during our 13-year orbit of Saturn, Cassini really found two intriguing astrobiological targets, the moon Titan and the moon Enceladus. We know they were intriguing before from some of the Voyager flybys in 1980 and 1981. And after all, astrobiology is the theme of this year's Space Fest. But you only have enough money to go to one. Yes, there is a finite amount of money in the world, and you're going to have to make priorities. So here's some things to consider as you put together your mission. What instruments do you want to put on your spacecraft? You can't put everything on top of a spacecraft, just not enough room, not enough mass, not enough power. And in fact, most instruments are trade-off between those three. If you give me a lot of money, then I can give you a very low weight instrument that uses very little power. But you probably only give me some money. So I'm gonna have to use some cheaper material that probably weighs more and uses a bit more power. But once again, you can't fly everything. And also you should consider that the more challenging a mission is, the greater the risk of failure. So that may be a really neat thing to do, but you realize it's really, really risky. So let's look at Titan first and then Enceladus. So this is a visible image taken by the Cassini camera. Hopefully you can see my little rocket ship. And here's an image of Titan, like you could see with your eye. First thing you notice is this really cute cloud that pops out at, I think, the south pole of Titan. But can't see down to the surface. It's all covered with this haze. So the fact that there's a cloud lets you know there's an atmosphere. And Earth has an atmosphere and Earth has life. This is good. And Earth has clouds, and so does Titan have clouds. More interesting. But you'd like to see down to the surface. So let's change the wavelength of light and go into the near infrared. And this is from the near infrared camera on Cassini. And you can start to see a little more structure in the clouds, and there's some hint down to the surface here. So clouds, well, what are they made of? Are they made of the same, like they're like water clouds, like the water clouds on Earth? Turns out they're not. And what is going on the Earth, our average surface temperature is about 59 degrees Fahrenheit. However, the average surface temperature on Titan is minus 290 degrees Fahrenheit. So the water on Titan is all frozen out. It's like rock. So water is rock on Titan. So these aren't lovely water clouds. These turn out to be methane, ice, and liquid methane clouds you're seeing on Titan. So that's sort of a bummer because all life as we know it needs liquid water to grow and reproduce. Life can survive being frozen, but without liquid water, as I say, there's no partying going on. So it turns out that the Earth's atmosphere is actually mostly nitrogen, and Titan's troposphere is the lowest level of the atmosphere. It's the weather layer. It's where we live. Titan's atmosphere is also mostly nitrogen too. And something really, really neat happens when you shine solar ultraviolet light and let charged particles hit a nitrogen atmosphere with methane in it. You get all these wonderful organic compounds for free, no life needed. So in this graph, brightness temperature, you can think of that as energy. And this is, you can think of wavelength. And each molecule emits energy at a specific wavelength that allows us to identify. And you see like hydrogen cyanide, propane, acetylene, ethane, methane, all these wonderful organics for life to munch on and use, but and they don't have to reproduce it. You don't have to make it. You're getting it for free. So there are other aspects that make Titan interesting from astrobiology standpoint, and like an Earth, is that like the Earth, Titan also has lakes and seas. This is a lake, and I'm afraid I cannot pronounce its name, at the northern, near the northern pole of Titan. It's actually 50% larger than Lake Superior, and it's about 500 feet deep. Because of the haze, what we have to do is use radar. Hey, Cassini had a radar on board its mission. We're basically bouncing radar off the waves off the surface of Titan. Where the surface is rough, the radar gets scattered back to the spacecraft. Where the surface is smooth and absorbing, no radar signal comes back. So you have this huge lake, maybe something living in a liquid methane lake, I don't know. But we got a bunch of liquid methane that we can use. And one thing I like about Titan is that comparing it to Earth, an Earth lake. So in an Earth lake, if you want to motorboat, you have to bring the fuel because the oxygen is for free in the atmosphere. If you want to motorboat on Titan, you have to bring the oxygen because the fuel is for free in the lake you're going on. The Huygens, remember I said it was the Cassini-Huygens mission? Well, Huygens actually landed on the surface of Titan. It was a probe, it had a heat shield and then a parachute, and it settled on the bottom. And so this is what a color image looked like it took once it landed on the surface of Titan, and here's a nice black and white image. First thing to notice is that, well, remember, these rocks are solid water ice, and they're coated with all that nice organic, lovely organic material. And notice that these rocks are rounded. Where do you find rounded rocks on the Earth? Along a lake shore or along a riverbed. So this must have been once a riverbed. Notice also that about the biggest rock is about 15 centimeters or 1.5 feet across. We're down in a riverbed, so that means whatever flowing liquid, it could only lift up rocks this big. Rocks bigger than that couldn't get pushed down. So that lets us know about flooding on Titan. So we got liquid methane, we got a bunch of organics. The thing that we're really, really missing is the liquid water. But Titan nicely provides that too. So there's also a gravity experiment on the spacecraft. It measured how Titan's gravity and tides on Titan affected the path of the spacecraft. And they were able to figure out that deep under, not deep underneath, not deep down to the core, but below the surface, there is a global subsurface ocean. Finally, I got my liquid water. Yeah, there's organics on top, and I may need to get some other organics down there, but maybe the water can come up. But this is why it's interesting for astrobiology. Even keeping track of all the instruments you need. So let's go on to Enceladus. This is actually a Cassini image of Enceladus. And the first thing you should notice is that, yeah, they're craters like we expect on a moon, but then these whole surfaces down here where there are no craters, or they're very small and very fresh, new craters. So that lets you know something is reworking the surface of Enceladus to remove the craters, the same way as erosion removes the craters on the surface of the Earth. We knew also that prior to Cassini, the Enceladus was special because it was as bright as new fallen snow. So somehow something kept changing the surface. So, going to maybe surprise some of you. Maybe some of you know this. Saturn has a magnetic field. You can think of it as having a big bar magnet in the center of the planet. It's really more complicated from that. So you have this lovely magnetic field from Saturn. And on board the spacecraft was an instrument called a magnetometer that measures the magnetic field strength and direction. Well, when we did a distant flyby of Enceladus, they noticed that the magnetic field was bent a bit. Something was going on. And that science team convinced everybody else on the mission, we should really fly by Enceladus closer the next time we're scheduled to go by. So we did. And I'll cut a bit to the chase. It turns out that there is water ice and water ice particles and gas being vented from the south pole of Enceladus. The gas then becomes ionized or picks up an electric charge that then affects the magnetic field. So this is an example of maybe why you want a magnetometer to let you know when you fly by a moon, something weird is going on that's worth looking at. So the next time we went by, they pointed the camera towards it. And this is a little, let's go back, a little GIF that keeps looping back and forth. And yes, there are active jets. And now we're going to like stretch the image incredibly. And you can see that there's a lot of structure in the jets. They're not just one big sheet, like a bunch of little holes coming through. So what's the composition? What's the temperature? Are these warm or cold? Once again, back to my favorite instrument, the one I worked on. Distant flyby, all you can see is that, yeah, it's warm down there. Let's fly by again closer the next time. You can start to see that the warmth is not uniform, but it's pushed along these cracks. So these are warm cracks. I don't mean warm like even outside today in Minnesota warm, much colder than that, but there's still cracks. They're warm. Underneath, it's probably even warmer, right? So let's fly by even closer yet. And now you can see as you go along one of these cracks, they're very hot spots and then there are colder spots. So this is continuously reworking, continuously changing. And as this material comes out, then settles back on Enceladus and erases all the craters. Haven't answered the composition yet, so once more we're going to do, we're going to fly through one of those plumes. And on board, there was something called the ion neutral mass spectrometer. This is an instrument that can measure the composition of gases. Maybe another instrument for your mission. Found a lot of water vapor, our friend methane, simple organic compounds, carbon monoxide and carbon dioxide, and some very complex organic compounds. Once again, I got liquid water, I got interesting chemistry going on. Maybe I should go back and see really what's going on from an astrobiology viewpoint. Okay, I'm showing this with a lot of caution. The surface jets, those have been seen and observed. So this is true. We know underneath there's a warm ocean. These white smokers, these are artists' conception. White smokers are found in the Earth's hydrothermal vent system, which was shocking enough because when I went to school and dinosaurs roamed the Earth, we were always taught life had to start on the surface of the planet because it needs sunlight for chlorophyll to make the first food. Well, it turns out that you can actually have life in the bottom of the Earth's ocean where there is no light. So also hope as part of your astrobiology, you're funding studies of extreme life on the Earth. And then there's also water-rock interactions going on. That's all your information. Hopefully you've made your pick. Here's your chance to see whether your pick matches up against what NASA picked. And we're actually going back to Titan with a really neat mission called Dragonfly. We're basically going to be flying a quadcopter drone around on the surface. That's pretty neat. Yeah. And one of the special things is you have to remember is that the light time to Saturn is on the order average of an hour and a half. So this really has to fly by itself. It really has to be robotic. You can't wait an hour and a half to see something bad, and then it takes another hour and a half for your command to go to the mission to correct it. So yeah, and that's really all I have to say. So I'm going to stop sharing. So take it away, Amber, if there's any time left, or I just blathered on forever.
Thank you so much, Paul. Sorry, I lost my screen there for a second and I couldn't jump right back on. So I hope that everyone had a chance to make a guess and make a decision as to whether or not they would have chosen Titan or Enceladus. Hopefully there were a lot of people out there that made those choices and those decisions. I want to thank you so much, Dr. Romani, for sharing this with us. One of the questions that I thought about, because obviously you've done a lot of work with instrumentation and the importance of instrumentation on these missions. And I'm wondering, like, what are some of the more creative ways that the teams that you've worked on or that you've worked with have come up with to be able to get more and more instruments on some of these spacecraft?
A lot of it is just incredible growth in the miniaturization of electronics. They require less power and they require less electricity, which is all good. The hard thing is that you have to remember that when we're flying a space mission, we are under this wonderful atmospheric blanket and magnetic field of the Earth that protects us from charged particles. So the charged particles really play havoc with electronics. Cassini was actually, prior to Cassini, every planetary mission actually recorded the data on magnetic tape. For those of us can remember magnetic tape or cassette decks, cassette tape, and played it back. Cassini was the first mission to use solid state memory chips. Even then, because of the charged particle worry, they got really clever. They would store part of the information on one chip and part of the information on another chip and make sure the chips were so far apart that if a charged particle came in and destroyed this part of the memory, you still had this working. You had this information going on it so you could recover it. That's just the first thing that springs to mind.
Yeah, it's amazing all the different skills on these teams and being able to come up with those really creative solutions. I do see some questions from the audience. The first one is from Daniel, and Daniel's wondering, how deep are these subsurface liquid oceans?
Short answer is, I don't know. I think the longer answer, there's still a lot of trying to figure it out. There are people will do like trying to figure out how much energy is available on Titan or Enceladus to do the melting from the tidal interactions. These are melts caused by tides. Saturn raises tides on these objects. And then you need to figure out what the composition is, because we all know that if you add certain chemicals to water, it won't freeze at 32 degrees Fahrenheit or 0 degrees Celsius. So if we know the composition, they're getting better at it. I haven't stayed in tune with it much because I'm primarily an atmospheric chemist in my day job, so to speak. I really enjoy trying to understand the composition of an atmosphere, how it's evolving chemically, maybe what it was a long time ago, and what does this mean for the future of the moon or whatever. Um, yeah, I can get back to you on it. I'm sure Amber has my contact information. If you give me a couple days, I can give you. But last I know, it's still an active discussion. And I don't know if Dragonfly will be able to answer any of those questions or not.
Okay. No, we can communicate some of those things back and forth, and I can actually type answers on our social media pages as we learn more. Speaking of Dragonfly, Maddie is wondering when the Dragonfly mission will launch.
Okay. I think it's scheduled for 2023, but I know, like everything else, it's gotten pushed back from COVID because you can't have everybody in the lab working close to each other. So I think it suffered a year's delay, but they're still moving ahead on it. I would have, if so, in that last slide, and Amber has the slides, that's the link to the main instrument mission website, and it's being run out of Applied Physics Laboratory here in Maryland. So that's actually the best place to go to and the best place to keep in touch. And I'm sure Amber can provide that link for you.
Yes, absolutely. We'll go ahead and post it in the comments so that individuals can check that out. So Mary, after going through this exploration of Enceladus versus Titan, is wondering what do you think is life is likely to look like on either of those moons if it exists?
I'm glad you say if it exists, because I want to see headlines. NASA scientist says life on Titan. No, it's probably going to be something like a bacteria or a microbe. And I say this because if you look on life on the Earth, it's interesting that we think life started very, very early on. So maybe it was easy for life to get going. But for about half of Earth's history, it really stayed at the one cell level. And even it was primitive one cells. We didn't have an organized nucleus. So if the Earth is average, big question, then it seems that life starts early, but it really takes a long time or something special to start putting together multicellular organisms like you and me. And I always wondered, what would be the big banner headline in a newspaper or big banner headline on Facebook or Twitter? NASA finds life in the solar system. And it turns out it's a bacteria. Would you all be excited? I know my first question is going to be, is it DNA based? That's what I want to know. Mm-hmm. That'd be amazing either way.
No, thank you for that. Several of our audience members actually picked Enceladus, and so they're wondering, why is it that you think that NASA didn't pick Enceladus, and do you think there's a possibility that it could be explored in the future?
I definitely think there's a possibility that could be explored in the future. There was a really neat European space mission that was proposed, and it got sort of up in the selection process, and they had this wonderful name, Tandem. It was Titan and Enceladus mission. We get very creative with acronyms. So it was a joint mission to both Titan and Enceladus. I got the idea for this talk from, because they found both were so interesting, they could not decide between the two. Short answer is I don't know. But I think landing by an active geyser may be a little risky. With Titan, at least, you got a thick atmosphere, you can parachute down, you can, I think Titan may have been a bit more easy. There was always interest in Titan, but Titan's always had the problem of being too cold for liquid water. Another interesting moon is Europa, a moon of Jupiter that is similar to Enceladus. It's not actively venting as much as Enceladus, but now we think it is venting. And also, this is just an incredible breakthrough. Back when I was in astronomy school, we always thought life had to originate on planets. And now 3 hot astrobiological sites in the solar system are on moons. So when you hear about exoplanets having life, you should think about exomoons. Maybe there's even more chances out there. So I'm not really sure, but I can ramble on for a long time.
You know, I think Daniel is, I think, speculating in some of the same ways. I think he's referencing Enceladus here when he's mentioning that, you know, life potentially forming from the water underneath. And he's wondering, how deep is the ice above that water? And is it shallow enough to drill through?
Once again, I'm afraid a short answer is I don't know. I'm definitely going to have to be looking up the recent papers on the thickness of that shelf of the ice. We're getting better at drilling. I mean, the Chinese recently had, I think they had a moon mission that brought back samples, and I think they went down a little over 6 feet, 2 meters. And that's pretty amazing for drilling, because remember, you have to pack everything and it has to fit into the nose cone of a spacecraft because you have to get it through the Earth's atmosphere. As I was talking with Amber earlier, one of the things that we're looking at now is actually origami. Because when you think about origami, it's amazing how you can fold everything up and then unfold it, and you have this wonderful complex structure. Well, why can't you do that with a spacecraft? So drilling is hard, but it's definitely the way we're going. Perseverance will be drilling and caching samples to bring back. I don't know, but it's definitely a question, and maybe you should go and study more about it and learn, and maybe you can figure out how deep it is. You don't have to depend on me telling you.
So speaking of these missions that are obviously very much spacecraft or rover or lander based, Mary has a question about, do you think we'll ever get back to a point where Americans in particular are doing personal exploration of space, or are we moving more in a direction where we're going to be relying on remote technology to be able to do that?
Okay, once again, my opinion, 2 cents. Is that there's definitely a push to return people, humans, to the moon to do exploration. Going to Mars will be difficult, but Elon Musk keeps trying to build a spacecraft that can go to Mars. He's had a couple setbacks of late, but he's quite willing to put his money in there. There's also always been a discussion about what's better, an intelligent robot or a human explorer, because a human can do some things that a robot can't do. We're getting better with artificial intelligence. We're getting better with manipulatives and things like that. The other interesting thing is during COVID, I think we're becoming far more used to about telepresence. Well, I can't go on vacation this year, but there's a really neat webcam at my favorite beach. And so I'll look at the webcam. We used to think that, people had to go to Mars, but if we could just set up a really neat webcam on Mars, what would you support? And we say we could do it for much less money. Remember, ultimately you have to decide where to put your dollars. So yeah, I'm being very wishy-washy, I'm afraid, because I can really see both sides of the arguments. I just hope we continue exploring by one way or the other, and we don't stop exploring. I think that's very important.
No, thank you so much. I really appreciate that perspective. I think it's important to acknowledge that there are a lot of decisions that go into these processes, and sometimes there may not be a perfect solution, but it's certainly fascinating to hear about all these missions that are studying other parts of our solar system. I know we here at the Bell Museum, one of the things that we are most excited about is the upcoming landing of the Perseverance rover on the surface of Mars, which is a good example of remote technology and how it can help us understand a little bit more about that planet. So I want to thank you so much, Dr. Romani, for joining us today and for helping to answer some of these questions and share them with our audience. For our audience that might be interested in learning more about the Perseverance rover, we are actually planning a special virtual star party that's going to be happening in February. And I'll go ahead and post that in the comments if you want to register for that and learn a little bit more. I want to thank everyone once again for joining us. There's lots more Space Fest to come. Our last program of the day is actually coming up at 4 o'clock. And you can join us at that time to hear more about the process of exoplanet detection. And so we hope to see you then. Thank you. And I hope you all have a wonderful day.